Welcome to Internet Quality Academy. The channel is for the civil engineer, site engineer, and the quality control engineer. In this channel, we are discussing about the quality control and the constructions. Today also, I am discussing about a very important topics that is for the construction and the quality control, which is why we are not cast concrete directly on the soil. Yes, we are not cast that one. We are taking PCC, BFS, whatever, but we are never doing it directly on the soil. What is the reason behind? Why? What will happen if we directly place the concrete on the soil? In this video, I'll discuss everything in details about this. So stay tuned until the end to get the full information about the why not to cast concrete directly on the soil trenches and what is the best practice to do that one. And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's start. What is the reason why not to cast concrete directly on the soil? First thing is moisture concerns. Now, if we are placing the concrete directly on the soil, there two things can be happen, that moisture from the soil can be come to the concrete, or the soil can take the moisture from the water from the concrete. The both ways it is harmful. Suppose the soil condition is very dry, and if we pour the concrete, the soil will take the moisture or take the water from the concrete, and what will happen, the water inside the concrete will be the less to do the hydration. What is hydration? Hydration is the process or the chemical reaction of between the cement and the water. So we poured inside the concrete the min required amount of water which is required to react with the cement to make it a hardened paste. Now, if the soil is taken the water, then there will be less water inside the concrete and it will not react properly with the cement. And another condition, that the soil has the moisture, so this moisture will come to the concrete itself, so there will be more water inside the concrete. Both ways, whether the less or the more, it is harmful. And the water cement ratio, which is very crucial to get the structural integrity, get the strength, get the durability, will be disturbed and will not get the desired strength and the durability. So that's why for the moisture concern part, we are not caused directly on the soil. Then is soil contamination. In the soil, we have their various ions, sulfate ion, chloride ion, and there are so many ions. Now, if we place concrete directly on the soil, these harmful chemicals and or the ion will start reacting with the concrete. And if it start reacting with the concrete, this chloride ion will penetrate, sulfate ion will penetrate, and it will eventually break the concrete. So the durability concern, the soil contamination will harmful for the concrete, and if we place directly, this can be happen, and ultimately durability concern will be a problem. So we will not place the concrete directly on the soil. Then the reinforcement corrosion. Now, if the soil penetrate from the chloride ion, from sulfate ion, penetrate inside the concrete, it will start reacting with the reinforcement. Also, if there is a weak path, the moisture also will penetrate inside the concrete and it will start corrode the reinforcement. And if reinforcement is corrosion is there, the volume will expand and there cracks will happen. And if the cracks will happen, the structural integrity, durability will not be achieved and the concrete will be failed. That the foundation failed, that means whole structure is failed. So reinforcement corrosion are also a criteria. That's why we are not place the concrete directly on the soil. Then another thing is shape and dimension. If we place directly in the soil, the required shape and the dimension we cannot achieve. And if the required shape, dimension, depth not achieved, that means we are not aligned with the design criteria. And if we are not aligned with the design criteria, that means we are not dealing with the structural integrity. Maybe the depth become less or the linear dimension is less. What is happening, this bending stress, bending criteria, so resistance, everything will be in a problem. So the design criteria will not be satisfied, and if the design criteria is not satisfying, what is happening, we are not getting the proper result, and eventually this will can be a structural problem. Then another things, we have the uneven settlement. That can be happen if we are pouring directly onto the soil, what will happen in the, if there is a undulation in the soil, then there will be uneven settlement, and if there is a differential settlement, what will happen, the crack will come in the concrete, and this crack eventually it is coming, and then the foundation will not be stable, and if the foundation is not stable, we are not getting the desired bearing capacity, and so that we cannot provide the structural integrity, which is the next part. So these are all moisture concerns, soil contamination, reinforcement, corrosion, shape and dimension, uneven settlement, which is happenings. This will ultimately ruin the structural integrity, because if we are not getting the concrete as per our the design or as per the requirement, we will not achieve the structural integrity, and if the structural integrity not happen, this whole system is not safe or the durable, it's not the durable. So whatever is our purpose to make it a durable and robust structure, that will not happen if we directly place the concrete on the soil. And then code and standard compliances, this code and standard compliance also said we cannot pour the concrete over the soil because of all these points. So that's why we need to comply about the code and standard, and that's why we are not allowed to cast the concrete directly on the soil trenches or the over the soil, because the moisture concern, soil contamination, reinforcement corrosion, shape and dimension problem, uneven settlement, structural integrity, and codes and standard compliances. So these are the reason why we are not cast concrete directly on the soil. So what will be the best practice? Then we need to prepare the subgrade. Also the soil we need to prepare properly, then we need to achieve the proper degree of compaction, the optimum moisture content, that also we need to check whenever we are placing concrete over the soil. And then one layer of PCC. Why this PCC layer will be act as a cushion? This is a labeled one and there will be covered. So these contamination of soil or the moisture penetration or moisture losing, that will not happen if we place a PCC over the soil and then we pour the concrete. Then waterproofing. This is a very much important. We need to waterproof the underground structure. Why? If we are not waterproof, then the moisture can penetrate inside the water concrete. So if moisture is penetrating, what will happen? And along with the moisture, the chloride ion, sulfide ion, they all will penetrate inside the concrete, and it will eventually break the concrete, and corrosion will happen of the reinforcement steel, and there will be thermal volume expansion, which will eventually crack the concrete. So waterproofing also is very much important if it is a substructure or the underground substructure. Then formwork, we need to do the formwork clearly and properly as per the design or as per the shape, whatever the depth, length, width, whatever, that we need to do the proper formwork, and then only we are allowed to pour the concrete. And then also we need to need the pouring sequence. What will be the pouring sequence? What will be the pouring height? What will be the pouring what from where we are starting? Suppose we have the raft foundation. Now we cannot start from anywhere. We need to start from some one places, or and we'll go layer by layer. That also we need to be very much careful whenever dealing with the substructure concrete. That pouring sequence also need very much essential. So these are the best practice: subgrade preparation, PCC layer, waterproofing compound, formwork, and pouring sequence. So these are the reason and these are the best practice for the concrete where we are not place the concrete over the soil directly. So I hope this information is useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I am waiting for your valuable comments. From your valuable comment, everybody will be benefited. And please let me know if you want to know anything about construction and quality control. And next time I'll come more content like this. Thank you once again for watching me.